this is nothing new for anyone. And I did say last week I would do better with my axes, but here we are. We have got two very important ways of expressing relationships, and I've harped on about this quite a bit. One is an equation, so y equals something, something, something to do with x. And then another way to express or describe or represent relationships is through graphs. And so what we're going to work with today is those two important representations of relationships. We need to essentially be comfortable with this stuff, because this is going to be important right up until matric in maths. And so we need to understand how to draw these things and how we get the different points and different coordinates as we go along. Right, so for those of you who haven't done graphs before, don't stress. Like I said, all of the videos are recorded. If you're not doing graphs this year, that's also absolutely fine, but you are eventually going to do it. And like I say, this is actually a very, very important section. So I would encourage you to stick around. Hopefully this gives you a bit of a head start into the graphs section. Alrighty, guys. So we know that when plotting graphs or when working with a relationship, I have two variables. I've got my input, which is my x, and I have my output, which is my y. And we know that to get our output, so the answer, for lack of a better word, we go and substitute in values for x. Now we can pick any values for x. It really doesn't matter. So you can make the choice. I'm going to make the choice for us here. So let's go -5, -3, 0, 2, and 4. Those are my inputs. So I'm going to do one with you, and then I'm going to ask you guys to give it a try by yourself. I think most of you would manage this, but let's have a see. If I look at my first input value of -5, I have got the equation y equals x plus 1. And so what I want to do is I want to substitute in my value for x that I gave you. So substitute in -5. Now I'm using brackets here for the values I'm substituting in. For me, it's just a little bit easier to work with. You don't have to, but when we start multiplying and dividing, it is quite useful. But here we've got -5 plus 1, which is a -4. So my output for that specific input is a -4. So just through substitution, I have been able to work out what my output is. Okay, so I'm going to ask you guys to spend 60 seconds trying to, or rather working out the outputs. If and when you have an answer, you're welcome to raise your hand, and then I'll get some output options from you guys that we can then fill in. I want to fix my axes because I've really made my life quite difficult here. Anyways. You're also welcome to remember, put your answers on the chat. That's absolutely fine. All right, I see lots of hands, so I'm going to pick on some people now. Hopefully I've got enough numbers here. All righty, Tiamo, would you like to give us the first one? Okay, I'm going to pick someone else. Tanankosi, would you like to give us the first one?
Hello, ma'am.
Hi.
Ma'am, -3 is -2.
Perfect. So -3 plus 1, output of -2. Fantastic. Well done. All righty. Nikki, would you like to give us the output for 0 as in my input?
I said 1.
Excellent. 0 plus 1 is indeed 1. Fantastic. Well done. Okay. Mukhadi, would you like to give us the output for the input of 2?
Ma'am, the output for the input of 2 is oh no 3.
3, well done. Okay, so guys, 2 plus 1 is 3. Tabang, would you like to give us the last one?
Of course, ma'am. Ma'am, 4 plus 1, ma'am. It's 5, ma'am.
Excellent, well done. So guys, we get all of our outputs here. Now, what we need to remember is that this sort of translates or relates back to the Cartesian plane that we worked with. Remember, you have got 2 values here. One of them is an X, one of them is a Y. And so what you actually have is a set of coordinates. So we have got a set of coordinates and actually a whole bunch of coordinates that we can now go and plot on our Cartesian plane. Please remember, when working with coordinates, it is always X first and then Y. So when plotting, we do need to be careful of that. But if we go and plot these points, let's go and see what happens. So our first point that we've got is -5, -4. So remember, X, then Y. So we go to -5 on the X, -4 on the Y. And I've really made my life hard here, but anyways. I'm just going to write in the coordinates because my axes went a bit weird, just so we know which point is which. I then got -3, 2, -2, sure. -3, -2, which is over here. My next point is 0, 1, which is here. I've then got 2, 3. And I finally have 4, 5. Right, and what we see as we plot these points is that if I were to join these points, I'm actually going to get a straight line. And so this is now what I want to do. And this is now the graph that we draw. Now mine might not go completely through. Oh, that's pretty good. Okay, so we've got our straight line. And so this relationship that we have described in the equation and then in the table and then in the graph is one of an increasing function. Now it is increasing because what we can see is that as the X values are increasing, so I went -5, -3, 0, 2, 4, I'm getting bigger and bigger. My Y values were also increasing. It went from a -4 to a -2, 1, 3, 5. And so what we're seeing is that my actual graph is increasing from left to right because of this increasing relationship between X and Y. And so this is why graphs are quite useful to us, because it shows visually that the relationship is increasing, that as I increase my value of my input, my output value is also going to increase. Alrighty, so please do take your screenshots before we move on to the next one.
It's time to shine. Take your screenshots, pips.
Rogelo, do you have a question for us?
Yes, ma'am, I have a question.
Yes.
Can you please repeat the things that you said about the graph? I don't understand it at all.
What things?
The graph, the whole thing about the graph.
Okay, I'm not really sure which part you want me to repeat, so I'm just going to recap what I said now. Basically, what we see is that with my input values, they are getting bigger and bigger and bigger. I'm going from a negative to a positive. And what I see is that the same thing happens with my Y's. It goes from negative and positive. So both of them are actually increasing. And so this is why my graph is actually increasing from left to right. If I move left to right along my axis, it's increasing. And so what that means is that this relationship described in the equation is an increasing one. And so that's why my graph looks like this. And this is all just found from getting inputs, values that we can pick, and working out the corresponding output according to the specific rule that I've been given. And so once I've worked out all of my outputs, I've then got a set of coordinates that I can go and plot onto my Cartesian plane. So all of these coordinates here, I've plotted on my Cartesian plane in order to then eventually join and form my graph.
Okay, ma'am, I understand now. Thank you.
Good, good. Alrighty, guys, so I'm hoping we all took our screenshots. I'm going to move down to the next one. Okay, so let's have a look at this equation. We have got y is equal to 3x minus 2. Once again, inputs, outputs. I'm not going to keep writing input, output. We know x is the input. We know y is the output. And now we need some input values. Now, again, guys, you can pick your input values. It really doesn't matter. As long as you apply the correct rule, pick whatever you want. But I'm going to give them to you so that we're all working with the same thing. Let's go -2, -1, 0, 1, 2. So I'm going to give everyone a minute to work out their outputs. If and when you're ready, you can put your hand up to give me an answer, or you can put it in the chat. Pontes just asked in the chat, will the coordinates always be linear? No, not necessarily. Right now we're talking about linear ones, but they aren't necessarily always linear. And we are going to look at some examples of non-linear relationships in a few minutes. Okay, so guys, remember you're substituting. Please remember that in substituting, you have some negatives here. So just make sure you're doing your order of operations correctly. Oops. Right, Palesa Modise, would you like to give us the first output?
Ma'am, it is -8.
Perfect, -8. Guys, just quickly for this one so that we all know why. Y is equal to 3 times -2 minus 2. Now, a positive 3 times a -2 gives me a -6. So -6 minus 2 is -8. So just be careful of your operations as you're doing your working out. Becky, would you like to give us the second one?
It's -5.
Excellent. -5. Fantastic. Lolita, would you like to give us a third one?
Ma'am, I got -2.
Fantastic. Well done. -2 when my input is 0. Amiki, would you like to give us the fourth one?
Ma'am, I got 1.
Perfect. 3 times positive 1 is 3, minus 2 is indeed 1. Spiwe, would you like to give us the output when the input's 2?
Yes, ma'am, and good evening.
Hello.
I think it is 4, ma'am.
Fantastic. Well done. So we've got 3 times 2, which is 6, and then 6 minus 2, which is 4. Alrighty. So guys, once again, we have our list of coordinates. I know there were lots of hands. I promise you there's still more opportunities for you guys to answer, so don't stress. We have our coordinates here. I'm just going to list them because I find it a little bit easier sometimes to actually go and plot. You don't have to list them, just in the same ways you don't have to label them unless I specifically tell you to label the coordinates in the question. This is all just going very wrong very quickly. But we've now got 5 coordinates I can plot. Right, so we now want to plot these coordinates. This is really annoying me that my coordinate system is so out of whack. You know, like, why? Hey, feel better about that. No, I don't. Oh,
That looks better though. We can see it.
Okay, there we go. Right, so let's plot these points. 1, 2, 3, 4, 5, 6, 7, 8, 4, 5. Guys, do you see how well I'm doing here? Three, 6. Hopefully you're doing better than me with your axes tonight, because sure. Okay, each of these little tick marks is just 1. I'm not going to fill in the numbers. And so now when we start to plot our points, remember X first and then Y. So my first coordinate that I want to plot is -2, -8. So I go to -2 on my X axis, and then I go to -8 on my Y. So there's my point at -2, -8. I'm going to fill in the labels just because I'm not putting in numbers. You don't have to. -1, -5. This point here. -5. We've got 0, -2. We then have 1, 1. And we finally have 2, 4. And so once again, what I see is that I've got a linear or a straight line being formed. Now guys, whenever it's a straight line, we do actually need to draw it with a ruler because it's a straight line. So we draw our line through our points like that, and we've got our straight line graph, which represents this relationship that we have here. Alrighty. Excuse me. So do take your screenshots. I want to have a look at one more before we take a break. This one's a little bit different, and we'll discuss why in a second. But do take your screenshots, guys. Don't want to miss out on anything. Lolita, do you have a question before we move on?
I do have a question, ma'am.
Yeah.
So in an exam, would they ever give us a graph to plot where it's not linear but curved?
They could. It would be quite a, I don't want to say a mean question, but it would be like a slightly harder one, but they definitely could. As long as you have got like a table and like an equation to work from, they definitely could. And we're going to have a look at some ones that are curved in a second.
Okay, ma'am. Thank you.
Deja. Alrighty, guys, so let's have a look at this last one before we take a break. Now, what I want you to notice here is the fact that my equation looks a little bit different because now it is a coefficient that is negative. It is a minus 2x. Before, if I go to B, that's a positive coefficient. It's a positive 3. Here, this was a positive 1 coefficient. So both of those coefficients were positive. Now I've got one that's negative. So let's see what happens when that is the case. Once again, I'm going to give you some inputs that you can go and work with. -3, -1, 0, 1, and 3. So I'm going to give you guys a second to work out those specific outputs while I move my axes again. Okay, I do see lots of hands already. I'm just going to give everyone another second or two.
Yeah, but
On it
people are like,
tonight,
I'm ready. I'm ready to do this.
It's good. Okay. Oh, okay. I feel like we're ready. Right. Let's see. Zalama, do you want to give us the first one?
Hello, ma'am.
Hi.
The first one, I got 7.
Good. 7. Well done. So guys, remember, -2 times -3 is a positive 6. Plus 1 is 7. So that's our first one. Fantastic. Sammy, do you want to give us the second one?
Yes, ma'am, it's 3.
Perfect. -2 times -1 is positive 2. Plus 1 is 3. Fantastic. Well done. Oh, Emmanuel, third one.
Oh, ma'am, it's 1.
Fantastic. -2 times 0 is 0. Plus 1 is then 1. Thank you. Theo, give us the Fourth one, maths.
-1, ma'am.
Perfect. -2 times +1 is a -2, plus 1 is now -1. Well done. Tendor, do you want to give us the last one?
I got -5.
Excellent. -2 times 3 is a -6, plus 1 is -5. Okay, so guys, once again, we've got some beautiful coordinates we can now go plot. I'm just going to write them down for us. My axes look a bit better, so hopefully this will be a painless exercise. And what I want you to now sort of start thinking about is, how is this graph different to the first two that we draw? So as we start to plot this, that's what I want you to start thinking about. So let's plot our points here. First one is -3, 7. Let me just make this a bit longer. So -3, 7 is going to be this point up here. Again, I'm going to label them. You don't have to if you don't want to. -1, 3. 0, 1. 1, -1. And finally 3, -5. Okay, so there are our points. We can now pop in our line. Remember, it's a straight line, so you'll use a ruler. Join all of your coordinates as well as you can. Obviously, this is just going to fight with me. And we have our graph. Alrighty, so take a second. What I'm going to do, I'll zoom in on it again, is I'm going to go like that. And can someone tell me how this last graph that we drew is different to the first two graphs that we drew? Yeah, Drew, that's right. You can put it in the chat or you can raise your hand. But how is this last graph that I've just drawn different? Tandawethu, do you want to tell us? No, okay. Okay, your name says iPhone and I know it's not your name, so you can let us know what your name is, and then if you want to tell us.
Ma'am, my name is Kitumeti, and ma'am, I think that it's going to the opposite side compared to the other one. So it's going more to the left-hand side instead of the right-hand side.
Good. Okay, so guys, what we see is that its direction is different. Okay, we'll chat about this now. I've just had a question of how are we getting these values? So just that you can see, I'm not going to do all of them, but I'll show you some of them. So for this output, y is equal to, we apply the rule I gave you, -2x plus 1. I gave you a x value, an input value of -3. So we substitute that in, and now we perform the operation. So a -2 times a -3, and negative times a negative is a +6. Plus 1 is then a +7. Whoopsie daisies. So that's where I get y equals 7 from. Just to show you on the other side, if I now do this one, we've got y is equal to -2 times +3 now, plus 1. And negative times a positive is a negative. So this would be -6 plus 1. And so I've got my output as -5 here. All right, so guys, that's sort of the method, for lack of a better word, of how we would get our outputs. And it's through substitution that we're able to find our y values. Okay. So what we've seen here is that this graph is actually now going in the opposite direction to what the first two graphs went. The first two graphs were increasing from left to right. This graph, as we can now see, is in actual fact decreasing from left to right. Let's pick actually the color we're working with. If we go left to right, this graph is decreasing. Now this makes sense. There's a negative coefficient, and so it is decreasing. We can also see that because as my x values are getting bigger, so as I'm going from a -x to a +x, do you see that the opposite happens to the y? I went from a +y down to a negative y. So as the x's were increasing, my y's were actually decreasing. And this corresponds to that decreasing relationship on my straight line. And this is why graphs help us or allow us to represent relationships, because we can visually see this increasing or decreasing relationship. Alrighty, so again, if you need to take a screenshot, please do. I'm just gonna make this a tad smaller so that you can see everything. And then we're gonna take a quick break before we carry on with some of the fun graphs, which aren't necessarily linear graphs. Okay, guys, now we're going to do the brain break the same way we did it last week, in that we're not going to give you anything help at all. We want you to try by yourself, and the first person who gets the correct answer will hopefully tell us what's going on. I want you guys to look carefully at this, and remember I said to you I was going to make it a bit harder this week. So look carefully at what's going on here, and then as you go along, put your answers in the chat, and we will take the first correct answer and you can explain it to us. I obviously need to figure out what the answer is. I did have it in my head and now it's gone. Sorry, everyone. Okay, be careful. Look at how many stockings you have, how many Santas you have.
We can do this, my babes. Let's see. We need the final answer. Let's see who's gonna be the winner of tonight's quiz.
Theo, let's see how we go for the next minute or so. Otherwise, I'll attempt to give you a hint.
We can do this, my babes. I'm not sure if it's my network. I cannot hear anything.
We're very silent. We're all struggling with our brain break.
Oh, I see. I see. My babes, remember that multiplication comes first. So if I was you to give you like a clue or so, try maybe the second, yeah, but try the second row first, maybe. Just realize the socks, how many socks you have there first.
That's what I was going to say. Look at
Yeah.
how many you have.
Yeah, the second and third row, I think it's what you need to try first, and then you can tackle the first row and then your final answer. Come on, my pips, you guys can do this. Just take your calculator. Let's see. Algebra needs to be done over here. Let's see. Things needs to be chuku chuku chuku. Needs to be chuku chuku. All the best, my babes. We can do it.
I don't know how much of a hint to give you. Both of these are even numbers, and both are bigger than 12.
Well, another thing that I had in mind, Teacher Sam, is remember how we always have our brain breaks and it's so quick. So they are allowed to take screenshots. If a certain time comes and no one got answer, we can actually use this the next lesson when
Next
we
week.
have. Yeah, like even this week on Thursday. Like this, everyone can think about it whenever you want, and we can just chill, yeah, and figure it out. Hey, my peps. I think
Yeah, so guys, I'll give us 1 more minute. If we don't have anything, then you're going to take a screenshot and we're going to try again next week. My hint, though, is the 2 Santas and 2 socks. Both of those are even numbers and they're bigger than 12. That's my hint.
Hint. Let's go, my babes. You can do it. But don't worry, because it's a brain break, right? It's cracking your head. So it's okay. If you don't get it, you still have Wednesday. You still have the next week, Monday.
Oh, yeah. Suppose we do.
Yeah.
I told you it was going to be harder this week. I wasn't lying. Okay, guys, I think take a screenshot. Take all of the hints. So Yolanda said maybe try start with the second or the third row. My hint was that 2 Santas and 2 socks separately. They're each even numbers and they're bigger than 12. Take those hints and mull it over, and we will see on Wednesday what answer we can try and come up with. We'll see how we go. Maybe I'll give another hint, but we'll see how where we're at on Wednesday. Spiwe, do you have a question?
No, ma'am. I think I've got the first one.
Oh, okay. What do you think?
I think it is 7 times 22.
Yeah.
I mean 7 plus 20.
Yeah.
7 plus 22 times 14.
Excellent. Well done. So guys, 22 times 14 is 308 plus 7 gives me 315. So Spiwe has given us a really, really great hint. So let's see on Wednesday who can come up with an answer. So take your screenshot. I think we all owe Spiwe a very big round of applause there. And so see if this now helps you get to your final answer. It should. Alrighty. Gonna give you 2 more seconds to take a screenshot if you want. Now that we've got some values. And let's have a look at some fun graphs here. Okay, so guys, what we need to be mindful of is, as I said earlier, we're not necessarily always going to work with linear graphs. It's not always going to be a perfect straight line. And so I'm loving all the rounds of applause. That was really well done. What we sort of need to expose ourselves to is the fact that my graph can almost take on any shape. And so this is a new graph that we're going to, or a new shape that we're going to have a look at rather. So here, our equation is y equals x squared. So now we've got a squared in there. Once again, input output. I'm going to give you some inputs to work with. -2, -1, 0, 1, 2. I'm going to do the first one with you just because sometimes exponents can trip us up and we don't want that to happen. So if we go and have a look at our first input, which is -2, we want to take -2 and substitute it in place of x. So I've got a -2 squared, which means that what I'm working with is a -2 times a -2, which means that a negative times a negative is a +4. So my output here is +4. So bear that in mind when you are doing your outputs with the square. All right, I'm going to give everyone a minute or two to fill in their outputs, and then I'm going to ask for the outputs, and then we're going to have a look at what this graph is going to look like. Remember that square. Remember what happens. Nice. Okay, I see lots of hands. I'm just going to give everyone another second or two. All right, Jose, do you want to give us the next one?
Ma'am, it's going to stay -1, ma'am.
Okay, so just be careful. If we're going to square a -1, we're saying -1 times, oh golly, -1 times -1. And what's a negative times a negative?
It's a positive, ma'am.
Good. So it's a +1. Well done. Okay, so we've got +1 as our output for -1. Palesa, would you like to give us the output for 0?
Yes, ma'am. The answer is 0.
Excellent. 0 squared, 0 times 0 is still 0. So we've got a 0 there. Well done. So Sitle, would you like to give us the fourth one? Okay. Tato, fourth one?
Yes, ma'am, it's 1.
Perfect. Okay, Sitle, let's try again. You can give us the last one here.
Hi, ma'am.
Hi.
Ma'am, the last answer is 4.
Good, well done. Okay, so guys, we have got all of our inputs and our outputs here. Again, don't stress, there should be time to do another one, so I'll give everyone hopefully another chance. We have got our coordinates. I'm just going to list them for us. Now, what I want you to notice is that your outputs are repeating. Here I've got a +4, here I've got a +4. Here I've got a +1, here I've got a +1. And this is going to form quite a cool shape for our graph that we're going to draw. So our coordinates that we have are as follows: -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. So now when we get to our Cartesian plane and we want to actually go plot these, remember x first and then y, again, because I didn't do the numbers when I should have. We're just going to work with the tick marks. Each one is a space of 1. So -2, 4 is plotted up here. And again, I'll just write it in so you know which is which. We then have -1, 1, which is here. We get to 0, 0, which is actually our origin point. But now, all of a sudden, we go 1, 1. And then we go 2, 4. And so if we look at the shape of this graph, this is definitely not linear. Okay, so there's no way I can draw a straight line, one solid straight line, joining all of these dots. So this is now where our curves come in. Right, now when we draw this, we just do the best we can. This is not going to be a V shape. It's going to be more like a cup. And so we get our graph. That is a terrible graph. I'm going to try that again.
We can see it. It's a pretty problem.
Okay, I think that's as good as it's going to get. Right, so it's like a cup shape. It's like a U shape. As Yolenda's just said, this is actually called a parabola. You don't need to know this. I'm just showing you some fun and interesting graphs. This will become important in grade 10. But for right now, you don't need to, my words are going to come to me. You don't need to stress about what it's specifically called. You just need to get sort of the shape. So Palesa, it's not a V because a V shape is actually a slightly different graph. And like we talk then about specific types of values, it's very much a curve. And so, excuse me, most of these graphs that we actually draw end up not being straight lines that actually have a curve to it. But it's not a V because what actually happens is that the graph sort of, if we were to plot, if we sort of were to zoom in, yes, on like this base part of my graph, it's never going to be a perfect straight line. It's going to form like this curved sort of succession of dots. And so if we join it, it is a curve. It's not a straight line. And so the arms don't go straight, they curve out and keep sort of extending outwards. I hope that answered your question. That sounded like a very long-winded answer. Right, so it's called a parabola. It's not a constant relationship because it's not the same thing happening each time. This is like a, I wouldn't say it's an exponential relationship. It's a quadratic relationship. So we're talking about values that are being squared. And so this is what our graph would look like if we're looking at a quadratic or relationship that we are using squares. Okay, so I'm going to let you take a screenshot.
You're doing well, my babes.
Okay, I'm going to skip this one just because it's quite similar. I want to chat about this fun looking thing over here. Right, so this should be giving you some flashbacks of exponents. This 2 to the power x. We should be thinking, oh, this looks like exponents. And it should. If it's not, that's okay, but exponents. So input, output. Let me just not make this too complicated for us. I'm actually going to leave off these last 2 blocks. Actually, no, let's not leave off these last 2 blocks. -2, -1, 0, 1, 2. So we're going to get, or we're going to substitute in. So let's just do the first one together. Y is equal to the power x. So y is equal to 2 to the power -2. Now, guys, you can put that in on your calculator. But if we remember our exponent laws, what this is actually saying is 1 over 2 to the power 2. And so what we have here is a quarter. Now, obviously, again, you can just put that into your calculator, 2 to the power -2, and you can get your output. But just remember, it is this answer because of the exponent laws that we learned, sure, way back when in the beginning of the year. I already see some hands. I'm hoping this is to give me more output answers. So Tato, Becky, iPhone, Emmanuel, I'm hoping that's for answers. I'm going to give everyone a chance to get some outputs, and then I will ask for some answers, and then we'll draw this graph and see what happens. Okay. Letu, would you like to give us the output when our input's -1? Letu, you there? Okay, Ria Betswe, would you like to give us the output when the input's -1?
Hi, ma'am.
Hi.
So, ma'am, the output for -1 is going to be 1/2.
Fantastic. Guys, this is a half. Well done. Paperdi, would you like to give us the output for the input of 0?
Yes, ma'am.
Yes.
The answer would be 1.
Excellent. Guys, remember, anything to the power of 0 is 1.
1.
Exactly. Well done.
Thank you, ma'am.
Thank you. Kaklehot, would you want to give us the output when the input is 1?
The answer, I think,
Is, sorry, you broke up there?
2.
Good, well done. 2.
I think 2.
Fantastic, well done. So 2 to the power 1 is 2. Onati, would you like to give us the last one?
Yes, ma'am.
Tell me.
The answer for number 2, the last one is 4.
Fantastic, well done. Okay, so guys, we've got these outputs here. Again, if we want to just write them out for ourselves, we can. Don't stress if you don't want to, it's really not a major. Now, guys, the quarter and the half, we just need to try and plot it as accurately as possible. It won't be perfect, but we just need to try our best. So when we plot this, just bear that in mind. 3, 4. And now we're going to try and get these coordinates plotted. Now, again, I want you to take note of the shape of the graph that we're about to draw, because it's going to be something a little bit different to what we're used to. And so let's go. So the first point that we need to plot is -2/4. Now, a quarter is not quite halfway. It's sort of halfway between halfway and the x-axis, if that makes any sense. So it's about there, just above the x-axis, not quite touching. And so there's -2/4. I'm not going to fill in all of these coordinates because it's going to get crazy. -1/2 is then sitting over here. Oh, come on. So halfway between 0 and 1, we'll find a half, and then -1. 0, 1, 1, 2, and then 2, 4. So if we have a look at these points, hopefully we all agree that it's definitely not a straight line. There's no way for me to draw a straight line to go through all of those dots. This is more of a curve. So I'm going to do my best. If we join these points, we're actually getting like a very slanted J-shape graph. And this sort of graph is what we call, and again, you don't need to know this, I'm just going to tell you for interest's sake, an exponential graph. Now, this makes sense. We spoke about the fact that this relates to our exponent laws. We applied our exponent laws here. And so it makes sense that's an exponential graph. Now, this actually has a lot of, well done, Nikki. It is indeed an exponential graph. These types of graphs actually have a lot of application in science, specifically like life sciences and biology. So if you guys, all of you do natural science, if you guys ever talk about like bacterial growth or even like population growth, often we talk about exponential growth. We talk about like the human population growing at an exponential rate, or bacterial colonies growing at an exponential rate. This is what exponential growth looks like. Basically, it starts off quite slowly, which is this beginning bit of my graph over here. So we're starting off quite slowly, but then we reach a point where we just increase rapidly, and that is exponential growth. And so things, I'm trying to think of like an animal, things like rabbits reproduce exponentially. They have lots and lots of babies, and like the growth is exponential. And so this particular graph actually has a lot of real world applications, particularly in science. All right, so hopefully we found that interesting. We learned about some new graphs today. There are definitely more types of graphs that we can be exposed to, but just understand all it is a relationship between an input and an output. Alrighty. So there is a poll, obviously. Pipedi, I do see on the chat that you have said you don't understand. If maybe you want to raise your hand, I'm happy in the last 2 minutes to try and answer your question, or you can put it on the chat and I can try help. Otherwise, guys, please do the poll. Don't leave until you've done it. Okay, Pipedi, what's up? Oh, I've got hiccups.
No, ma'am, I do science like in bio, physics, and chemistry. So like I don't understand. We didn't do this of growth.
You haven't spoken about it in science?
Yes, ma'am.
Okay, so you might not have, but if you plan on taking something like life sciences in grade 10, you'll definitely talk about this type of growth. So I'm more just telling you that it's one of the ways we can apply it in somewhere outside of math.
Okay, ma'am, I understand now.
Cool.
Thank you.
Cool. Okay, guys.
There's just one question that I think I shared with you, but probably didn't see my message, that if next time we could please have the method of how to answer these questions. I'm not quite sure how you can put it in methods.
Okay, so just to clarify, I thought, and maybe for whoever's question that was, for me, I thought this was showing you the method. I'm not going to do it for every single one because it's the same thing. But if that's something else that you want, please do let me know in the next lesson so that I know what it is that you